Alright, what's good, everybody? It's your boy Joey. Oh, get this fucking. Yeah, boom. Right there. Alright. Let me subscribe. How that sounds. See if that's too loud. Let me actually check to see how that actually. See how that actually does sound. Just give me 2 seconds. Yeah. Like that. And yeah, it's not gonna couple. It's not gonna feed through the other way, so I can do that. Just go here. Yeah, the music's pretty low. Oops, excuse me. The music's pretty low. Honestly, can't really hear it. Honestly. So let me turn up to 32. 32 is too loud. What up? No audio. Appreciate that. Hopefully, give me a thumbs up if you can hear my mic good. I just turned the music up just a little bit. 32. Yeah, I can hear that. Just enough. Alright, turn that off. I'll be looking good. We'll go back here. Alright, so we're gonna be diving back into the lab that we finished off last night. We were configuring RIP version 2 on all these routers. I definitely did some rookie mistakes with thinking about interfaces, networks, and stuff like that. Glad I went through it because I was kind of able to understand what I was, where I was mistaken on and stuff like that. Let me see. Right. By the way, what is this? Can you give me a quick breakdown? So this is Cisco Modeling Lab right here. This is pretty much just fundamental. The class, it's, I guess, if you were to take one of these courses, like the CCNA 200-301 course, but it's like fundamental networking with Cisco and stuff like that. This is one of their, yeah, you see from the thing. So there you are. So this is just where we're kind of at. But yeah, so where we kind of left off with the lab. Where we left off with the lab, we were. Let me get into this. So I don't have the to go back again. I have the switches actually powered off right now because there's a couple of things I want to fix. Obviously, I'm going to fix some of this labeling. The router's already turned on. I got them all already up and stuff like that. We saved the configuration from last night, which is cool. But I don't want to get these interfaces on these switches up just yet. And again, these are just unmanned switches. These are simply layered 2 switches. Again, if you're not familiar with the Cisco modeling, with Cisco or Cisco Model Labs, whatever, it's just a virtual machine. I'm running it as a server locally. Excuse me. With the free Cisco free tier, this is their 2.8.1 free tier edition. They're allowed 5 host nodes, 5 nodes. Some of the unintelligent nodes, like the unmanned layer 2 switches and the external connections, aren't counted towards you on that 5. So that's why I'm using these 5 routers here. Then I have the switches in between. But I just don't want the I want to just take a look at where we are configuration wise. Take a look at some of the messaging and then go through that. So that's where we're at. We're still going to be going through routing protocols. I did think we go back to the other lab that we did create, that we were originally working on. We go back to that lab, maybe do some things with access control lists with switches and stuff like that, and taking a look at that and see how that looks like in a PDU and stuff. So kind of where I'm at. Gonna continue on. Alright, so get this up. If you guys have any questions as we go along, just ask them. And we're gonna get into this here. So again, I'm going to be using probably a lot. I'll be using some stuff between David Bombal and Andrew. I believe it. What's his name again? I always forget his name for some reason. I don't know. Neil Anderson. You can find him on Flackbox.com, on the YouTubes, on the greater YouTubes. Link in the description for him and David Bumble's YouTube and their Udemy course, if you're interested in those. And I highly suggest, if you're interested in the CCNA 200-DR1, those are some of the good guys, some of the better ones. You also have the guy who wrote the book itself, David Weldon Odom there. I've taken classes personally with him, virtually, never in person, virtually. Another great one to look up and stuff like that. There's a couple other ones, but those are some of the ones I've always found is very helpful. But we're working our way up. This is obviously working our way up to cloud and Azure stuff, because that's one of the bigger focuses, cloud and Azure. But gotta start fundamentals. Fundamentals important. Work our way back up. Remember everything. So let's get into configuration we got here. Where we're at. This is 5. We'll start with some show commands. Show. We'll say interface. Let's see. Alright. So, looks like, yeah, we successfully were able to, everything did save last night after we shut everything down. So, we got our loopback addresses. Just trying to remember everything. Yeah, so, I believe, that this is the, kind of the, I'm kind of in the way of that. But with loopback, we did like 10.0.0. 1, 2, 3, 4, 5, whatever, real easy. And we, I say we, like there's fucking more of us. Me, there's many of me's in my head, I guess. But this is where I got hung up though, and I made made some, you know, real amateur hour. Just not thinking properly about interfaces and you know networks, traffic, stuff like that. I started thinking crazy out of my mind. But then when I caught myself, and I'm glad I caught myself, and I'm glad I went through it, because I was putting different networks, this whole fucking crazy IP scheme. I'm not saying on the switches, but on the router interfaces. I'm like, what am I thinking? I'm like, why am I not thinking about this correctly? And RIP wasn't working. So just to start off, I'm just gonna go simply through each router's configuration, see where I'm at, and adjust fire where need be. We're gonna be doing some RIP stuff. We'll connect links. We'll disconnect links. Then we'll obviously go into OSPF and some other routing protocols. This will pretty much be what this whole lab will be routing protocols. And if we got to break up the design, reconfigure things and stuff like that, that's generally the greater purpose of this and why I'm doing this. So that's where I'm at. So yeah, close that down. And if any of you guys, if everybody's having a hard time seeing anything, just give me a shout. Let me see. So yeah, you can see, this is the back address. This is router 5 again. So that's R5. This is where I was making some of the mistakes with, doing some of the interfaces and these weird network ranges. But Ethernet 0-0, that's facing R4. That's facing, so we have R5 here on R5's Ethernet 0-0. If we go back to down here on Ethernet 0-0, going towards R4 on R4's little network here, and we'll go R4 and I'll show you that too. And we'll just confirm that it's still there and it's correct. This should be in the 192.168.4 network. All right. I did put everything in a -24 network. Obviously, it probably wouldn't be like that. It'd probably be like lesser. The subnet addresses would be a smaller scoped. So there wouldn't be so many addresses out there for interfaces to just come up, in the same network or whatnot. But it's just my idea for now. I am challenged, you know better than me, say so. So yeah, that's where I'm at. We're all that, and we're just gonna go through it. So I am gonna change this to the 10 network that lives on R1's Ethernet 0-1 interface. So that's what I'm interested in doing right now on R5. So that's my intentions. R5. We're gonna change that to. We're gonna shut it down real quick. Shut it down. Change the IP address on it. 192.168.10, because that's a 10 network coming off of R1. And I'll show you that in a second. And we'll say .2. Yeah, 2.5.2.5.0. And I'll bring that up. Alright, so let's just take a look at that to show. So we're cool. So we got the address now of 192.168.10.2, and we're gonna go back to R1, and I'll show you why that is the case and why I did that. That's to what the goal is to hook up here to R1. This is where that 192.168.10 network is living. So coming off of R5, we're going to hook onto this switch, you know, being able to hook into this. That way, if we have a breach somewhere else, you know, we have a breach somewhere else in this network or something like that. Can't, you know, where's, you know, how is it all going to route to the traffic and whatnot? Yeah. So that's the plan. That's where we're kind of going with things and stuff like that, so you guys can have an idea why I'm doing what I'm doing. All right, so that's cool. We gotta fix this too right here. The network. That way it knows when RIP, because we have it right at no auto summary, so it's not going to be seeking you know, information about, you know, say if you have VLANs and stuff like that. It's not going to be seeking information about some of that stuff, which I believe with the summarization, I believe it does some of that stuff, that like if the router that speaking to it, you know, get some of that information and stuff like that. So we don't want to do stuff like that. This is a little staticky though, to manually set networks and stuff like that. Prone to error, I'm guessing. Yeah, so we just got to change that. Just got to change this real quick. We'll just erase that. So we'll log into the RIP. All right, so we're on the router RIP configuration terminal here. I'm going to say no network 192.168.5.0. And we are going to say network 192.168.10.0. Alright, so let's just check that work now, just real quick. Alright, very good. We removed that other entry and we included our new 10 network that corresponds to interface Ethernet 0-1. That's going to then, again, it's going to be hooked up here to R1 through the switch to R5, and then they'll be able to access that network through there. So alright, so that configuration looks good. Let's make sure we save that real quick. And we're gonna connect, we're gonna create a link. Back to the desktop, yeah, we're gonna create a link. And we'll add a link to switch. Yep. Create it. And how are we looking everywhere else? There's a question for the Chizat. Should we create a link here between R4 and R3? I think we should. Why the fuck not? I say good sir. Why the F not? go check out R3 real quick. Let's go take a look at that configuration. R3 real quick. Alright, so on R3, we got a loopback interface 10.0.0.3, Ethernet 0-0, that's in the .2, 192.168.2 network here. Alright, and then on its Ethernet 0-1, we have a 192.168.3 network. So, alright, what do we got for rep? So, we got the 2 and 3, correct. Come over there, 4. Alright. So where we at? This is R4 again. Alright, so we got a loopback interface, good. Ethernet 0-0, that is in a 2 network. The reason why that's in a 2, to remind us, the reason why that's in a 2 network is here's R2 right here. So R2 is connected to the switch. Again, this R3 has a 2 network as well. That's on 0-0. So we're connected to the same switch here as W2, and this is why on R4 on its Ethernet 0-0, it's a 2 network living there, right there. And then on its Ethernet 0-1, we have a 192.168.4 network. That's what's going over to R5 right there. So so that makes sense where we're at. Let's go back here. And we got a 2 and a 4 net. Perfect. So what I was thinking, let's go back to the desktop again. What I must think on Janai is off one of its other interfaces here, off R4. We can add it to the 192.168.3 network here to then things can be routed. We'll see how things can be routed that way to R3 to see if we, we're shortest paths and stuff like that. So we shall do that, man. Okay. We're on R4. Stop this down. Boom. So let's do a show IP int brief. Just want to see some of the other interfaces we got here that we got assigned and stuff. So we can use Ethernet 0-2 here for that. So okay. IP address 192.168 net. Again, remember that's a three network, so 192.168.3 network. Trying to keep things simple here. There's no other things connected there, so we'll go with 2. I should have probably come up with a better. Well, we'll change things. We'll change things, and we'll give that a no shot. Now maybe we start adding descriptions to these. I got spelled today. Huh? Alright, so we got now on our Ethernet 0-2 here, we have our 192.168.3.2 IP address. And this is in the state of up. Let's go back to our desktop here. And let's go here. Switch. Alright. Very good. So now we have our link on R4 on Ethernet 0-2. Like you see here, we put that in the 3 network, corresponding to R3 over here. So let's go to R1 and just want to do some show commands. We shouldn't have. Let's just see. So we got some information. So show IP. So perfect, cool. So currently we don't have any. Learnt routes from RIP. Obviously, we didn't. That information isn't retained. That's most likely saved in volatile memory. So once it's shut down, that doesn't get saved. If it was statically addressed, that would be stored in non-volatile memory. So once when it would start back up, boot back up, it would still have that in its configuration. So cool. So we don't have we don't have RIP doing anything right now. So then we can kind of see what RIP is doing. Maybe we'll inspect some of the wire to see those messages. See those PDUs come through, and we'll take a look at them and Wireshark. Wireshark. All right, that's actually a good idea to inspect that. So let's do that then. Let's come back to the desktop. Come over here. Which would be an interesting one. Gonna take a while too for it, but this would probably be a cool one to see. They're all gonna be cool to see, but whatever. Okay, let's get these old things started here. See if we can see. We see RIP message already starting to come through here. Capture a couple more packets. We'll capture 20 packets. We'll take a look at that. I'm not capturing too many. Alright, that's good. Now that. Today's the 12th. Perfect. Alright. We got some CDP. So we went over CDP. We went over CDP last couple of times when we first started doing the labs, and we kind of covered CDP again yesterday. How that's it, Cisco's discovery process. Pretty much, you don't even need to be. Really don't need that. You don't need any addressing. It's just it'll use the MAC address, and it'll just scope out to see if there's any other Cisco products out there, and they'll start sending information and neighboring and all kind of stuff. Helps you find out if there's stuff out there too. So where's this first? At least the first one we captured. We might have missed some, but we'll see where this one's coming from. Take a look at some of that. So where did we capture this actually? Let's take a look. Let's go back to that for a second. So we captured it all the way over here between R2, R3, and R4. We were looking at this line over here. So let's go back to that and see where some of the stuff came from. All right. So one of the first RIP messages that we captured here. This is coming from. There it is, source. So this is coming from 192.168.1. So let's verify which. Let's go. Which one was that again? 192.168.2.1. So that's coming from R2 right here, and we can verify that. Come over here. So on its Ethernet dash 0-1, we have 192.168.0. We have 192.168.2. So we got 192, and this is captured over right near, right in front of R4 there. Sending out RIP messages here. Pretty much sharing some information about some of the other networks it's aware of. So these networks right here, 192.168.1, that's, we go back here, and that's this is 192.168.10 network. This is 192.168.1 network. So R2 over here is sharing information about those networks out to these other routers here. Let's continue to look to see what else we see. So that pretty much for that one. We got ARP. We went over ARP. Here's another one. This is coming from R3 here. So again, R3 on its 0-0 port here. And we can just confirm that real quick. So on our Ethernet 0-0 here, we have 192.168.2.2. Come back to our packet here, and that's the IP address that we're sourcing. That's coming from R3, and they're giving us some information about the 192.168.3 network that's living somewhere off of itself, or it knows of that network. And that's down here too, if you guys can still see that over there. So cool. What else we got? Where's this one coming from? 192.168.3. That's R4. Again, we just actually did that, so that's R4, and R4 is sending out information about, you know, some of the stuff that R4 knows about. R4 knows about the 192.168.4 network. Again, that's living over here off of its Ethernet 0-1. Surprisingly enough, R4 does have information, and we can see it in there. R4 does have information about the 10 network. So let's go over to R4. I just want to make sure that I don't have that statically configured on R4 for it to know that. Well, let's just go to R4 real quick. Show run. All right, and it's not. So, confirmed. And that it, you know, we can see that that is, so the 192.168.2.3. Where if we go back to the PDU here, 192.168.2.3, which confirm that is R4's Ethernet 0-0 IP address. We can confirm we do not have the 10 network statically configured into its RIP configuration. So I'm gathering that it learned that from R5, and I would gather if we were to continue to watch these RIP messages, we would continue to see more and more information. Yep, and that's what we're seeing here. So this is coming from now, again, R2. It's coming from R2 again, and it's talking about the 10. It's talking about those two networks. What else we got? So we got RIP. Let's do a filter. Alright, so what's the next one? That's coming from R3 2.2. Again, it's just talking about the 3 network. 2.3, this is R4, and last but not least, another one from, okay. So that covers some of that, the RIP messages and everything that we've collected with that. So that was cool to look at in the actual PDUs. Now let's come over here to our terminal, and let's look at some routing tables that we should have now. So IP route, and we should have some information here that RIP has populated for us. So we're over here on R4. So yeah, and if we look over here, we have these kind of codes here. If we look at them, CR, CL, whatever. Come over here, we can see these are connected. Interfaces, links that are connected physically, they're going to have some intelligence about those connected interfaces and stuff like that. And we have static. We don't have any static. What's the next one? We do have, here's R for RIP, and we have L. I forget what L local. So local. There you go. L for local. So you have some local addresses, some local networks and stuff like that. But what we're mainly focused on here is what RIP has gained for us, some of the intelligence that RIP is doing here. So we got our first one here. So again, over here on R4, we've learned through RIP that 192.168.0.1, that network, and 192.2.0. So 192.168.1 and the 192.168.2 network. That's available via 192.168.1. So that's R2. So go back to our desktop here. So mind you again, so we're here on R4. R4 is right here. Alright, so via 192.168.2.1, which is available out of its Ethernet 0-0 interface, so it's 0-0 interface, and it's available on here at R2 at 192.168.2.1. So off of R2's Ethernet 0-1 interface. Alright, let's dive into a little bit more of the information we got here. What else did we learn from RIP? So we got that. And we do have a local link to the 3 network. That's how we've learned that. Okay. And we have a 4 network on us, and we've learned that 192.168.10 network is available out of our Ethernet 0-1 interface via 192.168.4.2. Go back to our desktop here, and if you remember, that is the interface here on R5 facing R4. So off of its R4's is Ethernet 0-1 interface, we can reach the 192.168.10 network. That exists here from R1 to R5 off of their Ethernet 0-1 interfaces. I feel like I got allergies kicking my ears. All right, cool. So we got that, man. Now I'll go back to here so you guys can see better. I'll go back to R1. Take a look at some of their R1's route tables. Just kind of take a quick look at everybody's route tables. Just want to see some of the information that we're looking at. So what we got from RIP? And we got from a couple of RIP entries right here. 192.168.2.3 and .4. Obviously 10 is a local link here, but all those are available. So 192.168.2 and .3 are available via 192.168.2, which is R2 again, which is available off of R1's Ethernet 0-1 interface. 168.4 network. So that is using its Ethernet 0-1, going through R5 to then reach it through R4. So go back to the desktop. And this is some of the reasoning on, and this is why I kind of made the loop with some of this stuff is RIP is deciding which routes it's going to take to get to certain addresses. Alright, so again, to get to 192.168.4's network, which that's here. So let me do this real quick. Can I illustrate? That's where that is. That's where that is, right here-ish. This one is 192.168.0. This one is 192.168.1.0. And then this one is 192.168.10.0. Perfect. All right. So hopefully that kind of helps you guys kind of see. Well, I can't see the 192.168.2 network, but that's that's this one right there, guys. All right, so the 192.168.2 network is right there. Yeah, let me just recreate that one. So I can drop that down. That's all right. You guys can kind of see it. So yeah, so to kind of get back to what Rip is doing here, we're on R1, right? Yeah, so we're on R1. So, what's that? Hola, señor. ¿Cómo estás? Bien. Sí. All right. So, here we go again. So 192.168.4 network, which again is living here. Rip has determined it is easier for it to go to R5 and then to that network, and it's costing, and this is good because of the cost here, because it's a less, it's less hops to get there, because each interface is a cost, and we're gonna get into that, and we'll see some of the show commands to see if we can see what that cost is. But say R1 here wanted to get to R4, but this way it would have to go through 1, 2, 3, 4 interfaces. 4 interfaces to get to the 192.168.4 network, where all it does have to go is 1, 2 interfaces. So almost half the amount of interfaces. Again, remind you, I'm not counting this one. So 1, 2, 3, 4 interfaces versus 1, 2 interfaces to get to this network. All right. What else? To get to the 2 and 3 networks, again, it's not going. It can go this way to get to 3. It can go R1 to R5 to R4 to get to R3, but it's choosing to go through R2, then to R3 to get to that. And the reason why, because it's less interfaces. So to get to R3, R1's going to go 1, 2, 3, 4 interfaces to get to R3 instead of 1, 2, 3, 4. Oh wait, so I guess that's the same cost, right? Yeah, it's the same cost. But again, it can go that way, but it's choosing not to. And again, to get to R2, so to get to 192.168.2 network, it's choosing just to go to R2, which again is only a cost of 2 interfaces instead of a cost of 1, 2, 3, 4 interfaces that it would cost to go this way instead of this way. I think I see. Come up. Keys. Can anyone tell me what concept he's teaching? So I'm just going over routing protocols. That's what's up. Kumar. Mr. Kumar. Let's go back here. Let's go back here. Got that. Okay, so we'll take a look. Let's take a look at some of the other routers too here, just to see where they're routing some of their stuff as well. So we'll go into here. We'll do douche. We'll show IP route. So come over here. This is R2, mind you. This is R2 here. It's taking to get to 3. So R2 to get to the 3 network. So R2 right here to get to the 3. All it's going through is it's Ethernet 0-1. Boom, right there, done. To get to 4. Easy peasy. Well, what's it doing to get to 4? Let's just take a look at that. Ethernet 0-1 via this interface right here. Perfect. Cool. And to get to the 10. To get to the 10 network. All right. So what R2 is doing to get to 192.168.10 network, it's sending traffic. It's Ethernet 0-0. It would make sense again because it's less interface cost to get to the 10 network via going out of its Ethernet 0-1, R4, R5 to get to the goal of the 10 network right there. So let's go over to A2. Let's take a look at some of this RIP information here. It's got to get to 1 and 2. Yeah, so again, this is R3 right here. To get to the 1 and 2 network, we're going to go out of its Ethernet 0-0, obviously to R2 on its interface here at 2.1. Easy peasy. Nothing really interesting there. Let me see. How is it getting to 4? It's getting to 4 via. Oh, that's interesting. And that's very interesting, cool too, because mind you, we do have a couple routes. You know, we have pretty much like a square here between R3 and R4, and R4 does have multiple networks via that it's available to, and R3 has 2 ways to get to R4 here that is the same cost too, in a couple different ways. So let's take a look at what we're doing. So to get to the 192.168.4 network, it is going via its Ethernet 0-0, and yeah, it's pretty much determined. So R3 RIP has determined that its Ethernet 0-0 port should be the port that it's routing all of the traffic through RIP RIP is, and this is cool to see. So RIP has utilized, and we'll check if that interface is up. So we'll check that too to make sure that interface is up, because if not, that we'll see if things change. But interestingly enough, it has chosen to, pretty much not send any of that traffic through there. Obviously, we have static, we have connected and local routes here, but RIP has chosen not to use that interface to get anywhere else, even though it would be the same cost for majority, to get to the majority of these networks here versus that way. Interesting. So let's just double check to make sure all of our interfaces are up. All right, and yes, all of our interfaces are up. Everything's up. So that's all good there. Go to R4 now. Check out that one. That's it. What is RIP Doom R4? So to get to 1 and 2. 1 and 2. So mind you, 1 and 2. It's going out of its Ethernet 0-0 port here. So to get to network 1 and 2, it's going out of its Ethernet 0-0 via R2. And what else? We got one more entry here to get to the 192.168.10 net. We're taking our Ethernet 0-1 right here. So, cool. And last but not least, we'll take a look at R5 just for completion purposes. Okay, so here we are at R5. And we got some, pretty hefty information here we've learned from RIP on R5 here. So to get to the to get to network 1 here, 192.168.1, we're going to go out of our Ethernet 0-1 port here via R1 to get to 2. Alright, so interestingly enough, to get to our 2 network, which is here, we're going to go out of our Ethernet 0-0 port. So R5 is choosing, RIP is choosing on R5 is chosen to go out of Ethernet 0-0 to R4 to get to the 2 network here. Interesting. And to get to our 3 network, mind you, our 3 network is here. How are we going to go through 3? Interesting. So to get to 3, our RIP on R5 has chosen to go out of its Ethernet 0-1 to R1 to R2 to R3 to get to network 3. Right? Yeah, that's what RIP has chosen. So let's do the math on that and see how many interfaces that actually costs. So that's 1, 2, 3, 4, 5, 6. That's 6 interfaces that's costing to get to network 3. That doesn't make any sense, because if it was to go the other way, it would only cost 2. So interestingly enough, RIP has chosen a longer way. And let me just go to, let's go back to R4 just to make sure that interface is up. Because that honestly makes no sense. Yeah, it's up. So the interface I'm talking about here is 0-2. 0-2, it's up. So that's very interesting. What R5 here is choosing, what RIP here is choosing to do with R5. Very interesting. It's alright. Let's get into
our interior gateway protocols and EGP, which is an exterior gateway protocol. Interior gateway protocols are used for routing within an organization. An exterior gateway protocol is used for routing between organizations over the internet. There used to be legacy EGPs, but the only EGP that is in use today is BGP, the Border Gateway Protocol. There are several different IGPs though. Our different IGPs can be split into two main types, either distance vector routing protocols or link state routing protocols. We'll explain what the different ones are and different routing protocol types are.
I'll back that up.
In this lecture, you'll learn what the different routing protocol types are. Our routing protocols can be split into two main types. That's our IGPs, which are our interior gateway protocols, and EGP, which is an exterior gateway protocol. Interior gateway protocols are used for routing within an organization. An exterior gateway protocol is used for routing between organizations over the internet. There used to be legacy EGPs, but the only EGP that is in use today is BGP, the Border.
Guys pretty much understand what he's saying with that. There was legacy EGPs, but currently, BGP is the only current protocol governing exterior gateway protocols. There's still a number of interior gateway protocols, and that's if I'm not mistaken, RIP is a interior gateway protocol, mainly used for smaller maps, smaller network maps, not larger exterior gateways. Route maps probably freaking look like. So, mind you, again, this is just RIP we're going over. We'll touch on some of the other ones, OSPF, and we'll go from there. So, continue on.
Border Gateway Protocol. There are several different IGPs though. Our different IGPs can be split into two main types, either distance vector routing protocols or link state routing protocols. We'll explain what the different ones are and which group they fall into coming up in a couple of slides. So in distance vector protocols, each router sends its directly connected neighbors a list of all its known networks along with its own distance to each of those networks. Distance vector routing protocols do not advertise the entire network topology. A router only knows its directly connected neighbors and the lists of networks those neighbors have advertised. It doesn't have detailed topology information beyond those directly connected neighbors. So because of this, distance vector routing protocols are often called routing by rumor. We can compare this with our link state routing protocols. In link state routing protocols, each router describes itself and its interfaces to its directly connected neighbors. That information is then passed unchanged from one router to another. Every router thus learns the full picture of the network, including every router, its interfaces, and what they connect to. Okay, so I know it's a subtle difference and it can be a bit confusing, and I've seen lots of people that actually are confused with this on the internet and spreading this information. So let's break it down what the difference is. With our distance vector and our link state routing protocols, both of them only form an adjacency with directly connected neighbors. So if you think back to our lab topology before, where we had R1, R2, and R3 in a row, R1 and R2 are going to talk to each other, and R2 and R3 are going to talk to each other and share information with each other, but R1 does not talk to R3 directly with with the routing protocol. Okay, that's for both distance vector and for link state routing protocols as well. So both of them, the routers only share information with their directly connected neighbors. The difference is that with distance vector routing protocols, those updates are from the point of view of the neighbor. The neighbor says, I know about these networks, and this is what my distance is to each of those. With link state routing protocols,
I want to let me get rid of that one. I want to let's go ahead and take a look at capture some packets here. I want to see it. I want to just take a look at what's, you know, some of the messages that's going on here. That's being populated. Is there any? There's a loop. There's a CDP. All right, so we do got some RIP. I want to take a look at some of those RIP messages now that a lot of the route tables and whatnot have been, for the most part, populated on all of the routers there. So let me just come here. I'll just filter this by RIP real quick. Grab a couple more. Maybe. No maybes? One more for good measure? Alright, that's enough. Alright, so we'll take a look at that first RIP message here now. And it's see again. We're still in this room, so we were right here on Ethernet 0-1, right next to R4 and R5 here. And mind you, this this interface IP address is 192.168.4.1. This IP address is 192.168.4.2. So what do we got here? So form source 4.2, that would be router 5. So R5, it's sending us some information here about 192.168.1 network and that and the 3 network and the 10 network. I wonder if this is the cost right here too. T. Is the next hop, and then I'm pretty sure this is the cost, because what's measured that out actually. Let's actually do that, and we'll determine that, and then I would like to see why it's then that. What router was it that was making some weird choices? Oh, of course. Was this one that was making the weird choice? This is R5. Oh, no. To get to 3. Was it? To get to 3? Yeah. So it was R5. To get to 3, it's going out of its Ethernet 0-1 for a bigger cost. So we might have to capture packets here, but let's continue to look at the packets that we've already captured, and we'll see why. Because it is actually mentioning 3. Mentioning 3 there for cost of 4. And if we go back here, so mind you, this is the 3 network. So R5 is saying that R3, that network 3 is available at a cost of 4. Is it saying? It's just saying that. See, I don't. We'll have to see what the metric 4 means, if that's what I think it is. Because if we take a look here, 192.168.0 network, that's here. So honestly, yeah, if you count that, that is a cost of 2. So that's 1, 2 right here. Those 2 interfaces. And yeah, that makes sense. Cost of 2. So let's go here to the 10, and yes, that's a cost of 1. So this is very compelling. Very compelling. So again, and I'm right, so 5. So R5 is telling R4 that it can get you to network 3 for a cost of 4. How is it coming up with that cost? That's 1, 2, 3, 4, 5, 6. It's still the same. It's still 6 to get to 3. So how is R5 coming up with that? And is that it too? Is that the metric there? Still, that metric doesn't add up to what it's... what it's saying there. No, it can't be, because this is correct. It's cost of 2. This doesn't make no sense though. We'll have to dive deeper and to see why it's coming up, how it's coming up with that. All right, so we got it's the response back out. This is R4 responding to its information. R4 is pretty much saying that, you know, to get to 192.168.1 network, it only cost me 2. Am I not advertising? Let's take a look at R4. Maybe I'm not advertising the 3 network through R4. That would make sense, because it's not even informing R5 about the 3 network that clearly exists off of its interface. It exists here off of its 0-2 interface. So let me go take a look at that. I'm curious now to know on R4. So we'll go to R4. Okay, so no, I didn't want to go into that. I want to just show some information. So show. correct. Good, sir. So let me just, so you guys can see what I'm seeing. If you can't see. I am not advertising. I did not statically, configure in RIP that there is a available route to get to the 3 network. Very interesting. I'm glad I did not do that. I'm glad I didn't do that, honestly, because that's so I can see that and see why that's happening. You know, yes, you know, R4 is smart enough to understand this network is available off of its interface, but it's not automatically advertising that. And obviously I turned off auto summarization. I believe that's part of that. Because it's not, you know, if I'm not statically doing it, it's not going to go out of its own. I gotta go on my damn way, girl. Tell you some bullshit. So, interesting. Glad I didn't do that, so that way I can catch that. Now, I'll change it. I'll update RIP on R4 to then advertise the available route here to network 3, and we'll see if R5 changes its perception about life. You know, might have a coming to Jesus moment. All right, that's that. So we'll say router RIP, and we're going to we're in R4. Come up here so you guys can see what I'm doing. So we're in router configuration, RIP configuration, terminal mode here, and we're gonna simply advertise now. We're gonna statically update RIP to advertise that we know a way to a network. We know something, man. So 192.168.3.0. Okay. Now remember, go back to the desktop before I do this here. Remember, we'll say, come here, and you guys can look at that again. R5 is currently going. Where is it? Yeah, right here. It's currently going out of its Ethernet 0-1 interface, which is this interface right here. It's going all the way, it's going through this switch, going through R1, going through R2, all the way to R3 to get to the 192.168.3 network. And simply, you can go out of its Ethernet 0-0 interface here and just go through 2 interfaces on R4 to reach this for a cost of 2 instead of a cost of 6. Because mind you, each interface is and this is where I'm confused, where it's coming up with the cost of 4. I don't believe the cost of 4. There's no way, because it's 1, 2, 3, 4, 5, 6 interfaces it should cost. So I want to know why that's only saying 4. But that's where it's at. So cool enough that we caught that. I'm very happy. Well, I'm happy I created the problem to then be able to figure out the fucking problem. See what I'm saying? See what I'm saying? See what I'm saying? Alright, so let's see if that now changes things here. What the? R5 just evaporated, just exploded instantly. It was like I was wrong this whole time and you were right. You were right, Joe. Alright, so now that we've updated it, good. Again, perfect. So now RIP is saying to get to the 3 network, we're now going to go out of our Ethernet 0-0 interface to R4 to get to 3 network here. So cool. I'm glad we caught that. I'm glad I created that problem too, so we can kind of see what RIP is doing, the choices, why RIP is kind of doing what it's doing. It's what makes these labs interesting sometimes. Let me see what we got going on, brother. Yeah. I do want to. Let's come back to here. Oh. So these were older again. These were older things coming from. Again, it was coming up with this cost, and again, this has to be the metric here. This has to be the cost. Now, is 4 just an arbitrary because it's just greater than 2 type of thing, or was there a way that RIP was finding a path that only cost 4, which I can't see how. And I'm pretty dumb, but I thought I set this lab up myself. So mind you, R5, RIP was saying that to get to 192.168.3, it was going to go on E1 to R1 here, out 0-0 into R2. But now it wouldn't go that way because again, R4 wasn't advertising even a way to it. So still, it would have to go because there's no other way. I don't have any other links. It'd still have to go through R3 on those 2 interfaces. So again, this is 2 interfaces. This is 2 interfaces. Again, this is 2 interfaces. I'm not counting the switch and what it's doing there. The router interfaces. But I will, for now, let me just ask this. Tape. I swear I broke ChatGPT yesterday. I broke it a couple times, but I swear it was dying. It's on its last leg. Okay. I need show most metric Alright, let's just see if there's some show commands or something like that that I can pull up. Maybe, let's see, is it simply this show G rip fucking fly. Broke ChatGPT again. Whatever. Show IP route rip. Alright, let's see. Yeah, it's not. It's still giving me this, and I know that's probably some kind of account, but it's not the account I'm looking for. ChatGPT's dead. see. Shows the administrative cost and the metric. But this metric, that's not correct though. To get it to, maybe it's its own metric. Still can't be right. I'm looking for. Let's do this then. Database. Summary. Detected. So RIP allows for a maximum hop of 15. A hop count of 16 is considerably unreachable. So RIP has a maximum hop count of 15 before before it's like it can't collect that amount of information anymore. It's just that it exceeds its maximum. That's why I believe, I haven't got there yet, but I believe it's just an interior. It's just considered an interior routing protocol for smaller network maps, not larger, bigger, greater. Equal cost pass if multiple paths have the same hop count. RIP can perform load balancing across these paths. By using the above commands, you can monitor. But it's, I don't believe. Yeah, it's not right though. Save some of my configurations too. I hope. In case anything happens. So we take a look at R1, and it's saying .2, the 2 network, two networks here, it's saying 1 hop. So if it meaning 1 hop by 1 router, I will agree. I will agree. I will concur to that instead of it being interfaces. Because it's saying for the .3 network. RIP is actually giving me 2 paths to the 3 network. Alright, so we have RIP doing some load balance in here now. So maybe it's updating. Maybe RIP is starting to update more and more as a lot of those PDUs now are being passed around. It looks like via either one of my interfaces here on R1, I can get to the 3 network only 2 hops away. So 2 hops. So it's saying I can get there. So 1. Yeah, I guess 1, 2, right? And then 1, 2. Yeah, so 1, 2, and 1, 2. Because we're counting routers, not interfaces now. So there. Yep. Very good, very good. And it's saying for the 4net, obviously, out of its Ethernet 0-1, so 1 hop. Oh, let me save that configuration too while that's there. Make sure everything's being saved. Break my microphone. And 3, so this is R2. Let's get to 3. Saying to its. Alright, so it's telling me. Okay, so yes, it has the 2 paths there. So again, it's load balancing. RIP is load balancing on R2 here to get to 3. It's saying I have 2 available. Well, 2 available routes to get to the 3 network via those. And 4, so 2 to 4, 2 to 4, correct. And then to 10, yep, 10 via R1, correct. Looks good. Okay, let's take a look at R3. So we have any interesting data here to go over. R3, mind you, R3 is here. Let's get to 1. We're gonna go via R2 to get to 4. To get to 4, we have 2 routes to get to 4. We have via, so here's 4 again. So we have 0-1, and that's giving me a count of 1 to the 4. And again, it's giving me over here on R4 2.3. That's 2.3. That's its interface right here. Ethernet 0-0. And again for another 1 count, 1 hop. So cool. And to get to 10, it has 3 available routes to get to 10. R3. So mind you, 10 is here, and it's all giving me a cost of 2. So R3 is saying via 3.2 out of its Ethernet 0.1 port here. So we're going to go here. It's going to say 1, 2. That's what it's saying. And then from 2.3, so from here it's saying we're going to send it out of its Ethernet 0.0, go here to 2.3, and then to the 10 network. So again, cost of 2, 1, 2. And then here it's saying we're going to send it to get again to here. We're going to send it to out of its Ethernet 0.0 from R3 to R2. That's R2's address on this interface right here, and then via R1 to get to 10. So 1, 2, all cost of 2. All right, so I understand that now. I'm glad I went over that. Save all these configurations. Seems like everything's working. We still haven't tried to ping anybody just yet, but we'll do that here. But shortly, I'm pretty sure. Pretty sure we'll be able to. Let's just finish up here. What we're looking at. All right, so on R4 here. R4. So R4 has locally locally connected. Three out of the 5 networks R4 has locally connected to. So realistically, R4 only really needs information about 192.168.10 and 192.168.1's network. So these 2 networks right here. And that's what we have described here in its IP route under RIP. Here is we have 192.168.1 and 192.68.10. And we have them both at 1 hop away. And it is using its Ethernet 0-0 to go to R2 to get to 1. And out of its Ethernet 0-1 to be expected to get to 10 right here. Perfect. Everything's looking good. Pretty sure we checked this one. This was the first one, so we were able to identify that hole. In the first place. Just gonna take a look back image. Okay, cool. Again, R5. So R5 is locally connected to 10 and 4. So it needs information about 1, 2, and 3. And that's what we have. We have 1, 2, and 3 here. And it's saying everything is 1 hop away. So get to 1. We go via this route right here to get to 1 through R1. To get to 2. To get to 2, we're going to use R4 to get to 2 right here. And to get to 3, because remember, this is where we noticed that we had our issue. Is R5 was taking this route to get to R3, and that does make sense now because it was showing a. We'll go back to that. So we still have the PDU up here, right? Yep, it was showing a cost of 4, so that's a router cost. So to illustrate that again, go back. So R5, so 1, 2, 3. Where did it come up with the cost of 4? I don't know. Interesting. Because to get to there, it would be realistically a 1, 2. It would be a cost of 3 because either this was the way it was taking though. It was taking this way because 3 was the only one. 3 was the only one that was advertising for this network. So yeah, it'd be only a cost of 3, not a 4. But it was also advertising to get here as a cost of 2. So the metric, I'm not sure the metric is the cost or if there's like a +1 to that metric or whatnot that I'm not aware of or privy to. But yeah, these are all off by 1. You know, it's all off by 1. Yeah, so maybe that's the case that the metric starts at 1. Obviously, it's locally connected. It's locally connected, so maybe it's counting itself into that metric as a hop, and then when you look at it on the actual router, it's deducting itself from that metric here. That would make more sense because it's counting itself. It's counting itself plus 3 others. It's counting itself plus 1 other. That's how we're going to get that cost right there on that metric right there. So that makes more sense. And this was 100% accurate at the time. And we've corrected that now. And yeah, because now we have it down to a cost of 1, which that would show 2 if we were to go back and capture those packets now. Cool. So that's RIP. We saw, you know, we can see some of the load balancing and some of the other ones, some of the other routes and stuff like that, and what it's kind of doing there. Very interesting. You know what? I'm gonna shut this down right here, so that way that's not just plain. Very good. Let's go back here.
The routers still talk to their neighbors, but they say, hey, these are all of the routers and their links that are in the network. And the information passes along unchanged. It does not get updated from the point of view of that router like it does with distance vector routing protocols. So with link state routing protocols, the routers have a full picture of the topology, and they have a reputation of being able to make better routing decisions because of this, but link state routing protocols do put a bit more load on the router because it's got more information there. Okay, so let's take a look at what the different routing protocols they are and what type they fit into. So our IGPs are RIP, the Routing Information Protocol, EIGRP, the Enhanced Interior Gateway Routing Protocol.
So, well, I was wrong about that. RIP is considered a distance vector, not link state vector. Which makes sense because we were counting the distance, but I was confused with links. But if you guys can excuse me just for a couple of minutes here, I'm just going to take a break, and I will be right back, guys. 2 seconds. Do some dad jokes. Alright, I'm back, everybody. Thanks for being patient with me. Just went outside, smoked a quick cigarette, and I was thinking of, I guess I was thinking more into the, the theory of RIP and um, why you, why it's really not used as a border protocol. Now, mind you, we could have RIP auto summarizing. This is I'm just gonna get into this because when I was outside smoking a cigarette, I was just thinking about what RIP, what RIP represents and what it's doing. So, if off of R5, we had a switch. That switch had VLANs here. Now, mind you, none of these current routers are doing NAT. So, if I did, maybe we can do that too. If I did have, and we can see if I'm correct on this theory, if we did have a switch broken off and we had VLANs, we had hosts on those VLANs, and say we wanted to, reach something over in 192.168.3, the 3 network here. Now, without doing NAT on any of these routers, what I'm thinking in my head is the host would be able to send the packet to R5. R5 with NAT. Now, mind you, we're not doing auto summarization, so none of these other routers know any of the other information that I'm not providing it via what I'm configuring it. So the R5, when it gets to PDU, it would know, potentially if it had the address. Again, mind you, if in the 3 network, the address I was looking for, was one that, potentially we'll say this interface right here, because we have an address where this interface is, and that's 192.168.3.1. So if we had a host over here, maybe on some other network, some other private network, and it was to ping this host, this interface here, I would gather that R5 would be able to send the messages to R3. But R3 would not know where to send the messages back, because the source IP, it would not recognize the source IP address. Because R5 is not doing NAT, it's not translating that address to a network that R3 would recognize, and then R3 would fail to then forward that response back to, say, a host here on R5. Yeah, I would just have to power down one of the I guess we can go to the other lab, because I would have to set up a switch. I would have to shut down 2 devices. I can still do that. I would just have to shut down 2 devices. I just have to shut down 2 devices because I would need a switch and then create the VLAN. Or I can just create a virtual interface. Yeah, I can probably just create a virtual interface off of that just to. No, I don't think that'll work. Or I could just, yeah, because the source IP would come from. Yeah, so let's actually try that. So what we'll do is we'll power down R1 here. Let's just make sure R1's configuration is saved. So I want to make sure that's saved before we power it down. Yeah, we'll use. We'll power down R3. Well, which one should I do? It really doesn't matter. Alright, so we're just gonna power down R1. Screw it. And then we'll just, actually, we'll do blocks that off. Well, that gives it a route to get to either way. So power 2. Power these two off. I'm gonna have 2 hosts. One off each one. Yeah, they'll never be able to talk. Okay. Let's do that then. So let's power off our R1 and 2 in this example. Okay. Successfully off. Come here, we'll stop you. And we'll do what's this? Got nodes. Grab a server. Yeah, we can hook the server actually up to hit. Yeah, because it's still on that same. It'll still be on that same interface. I know you guys can't see it, but it's right there. So same for you too. So you can be right there, and then you can be right there. And we're gonna call you host 1. Host 2. No, oh, because I want them on. Well, I could put them on. Okay, so we'll do 2 principles. We'll lab it 2 different ways. So this is how we'll do it. This is how we'll do it. They're gonna get messed up. Not too bad. Still kind of see. No, I'm in the way. But yeah, you can see. So here, let's move first one here so you guys can see this shit. So this again. Yeah, you guys can see it. so even Stevens. All right, so what we're gonna do first is we'll connect these toasts to networks that are known within the topology. And then we'll create networks that are not known to the topology. And we'll see if we can see if we'll be able to ping anything. So if we come over here, I'm gonna start this little guy right here. Start this guy right there. Add a connection here. Alright, so host 1 will give an IP address in the range of the 192.168.10/24 network, and on host 2 we're going to give an IP address in the range of the 192.168.3/24 network here. Okay, so currently we don't have an IP address. Correct. We're gonna change that right now. We're gonna say sudo config, and we're gonna say 192.168.10. We're gonna say 10 with the net mask of 25. 25.0. Say up. I always put a conga, the conga, doing the conga line. All right, so if we run IF con, not conga, big, we should have an IP address. No IP address, maybe. Oh, dumbass. Dumbass. Ah, well, there's our address. 192.168.10.10. So, realistically, we should be able to ping the interface that's facing us. So the interface on R5, which is, if I'm not mistaken, we'll go with that real quick. We'll just check that real quick. And off of 0-1, that would be 192.168.10.2. So let's go back to here. We'll see if we can ping 192.168.10.2. And we can. So we can ping ping R5. Let's down a little bit so you can see that host again. So host 1 here, give it the IP address 192.168.10.10. We can ping R5's interface here at 192.168.10.2. We should realistically be able to ping anybody else too, mind you. Just test that out here. Go back to so mind you, we should be able to ping, say, who did we turn off? Oh, we turned off R2, R1 and R2. So let's ping R3's Ethernet 0-0 port. Oh, excuse me. Which is ping 192.168.2. So that's 1, 2, 3. So that'd be 2. Because we don't have a gateway set up. Let's set up a gateway. I believe it's. Let me just figure out the. Like a big pizza pie. Rest of killing me. Alright. Let's add a default gateway. So do sudo route default. I can spell default right. And then we're gonna say 192.168 dot what is that? Yeah, 10.2. Alright, so if we now try to ping that, now we can ping that. So now that we got a gateway. So now that let's go back here. You guys can see. So from host 1, I've just statically configured as R5's Ethernet 0-1 as our default gateway. So when it sends something out there, it's pretty much just depending on R5 to route it out. And we pinged 192.168.2.2, which is R3's 0-0 interface here, so we were able to route our traffic through here, and curious, the decision was probably made here to do that. I'm gathering to route that there. Okay, now again, this is because this host is in a known address. All right, this host is in a address that's known throughout the network. So let me change this host. Actually, I shouldn't put it on another known. Let me put this on its own unknown address. Now the router is going to know. The router is going to have some information about where this host is, but none of the other routers are going to, because this network that we're going to create now, and I needed to do this, so we don't want it to be linked here. Delete that link. Okay. And we're going to instead, yeah, we'll put it on R4. R4 just has all. R4 is that girl, man. Just run them straights. But we'll connect to R4 and we'll create a new, add a link here. Cool, so we'll go to R4 now. And we're gonna create that new network now. So do a show brief real quick to verify the Ethernet one that we're not using currently, that we're going to be using, is Ethernet 0-3. So let's get into configuration. Terminal mode, not the conga line, Joe. All right, so interface Ethernet 0-3. And we're going to, what IP address are we going to use there? You know what? We'll give it, put it in a this IP address. We'll say, I mean, it could be any friggin' thing. I just don't want it to be, yeah, okay. 192.168 dot, we'll say, let's say 40, yeah. 40.1, perfect. 255, 255, 255, 255, nope, not 0. We'll give that a no shut. Now, mind you, we're not going to advertise this. We're not going to advertise this via RIP either. Mind you. Okay? So we're not going to advertise this. There real quick, and we'll just show this to confirm. Okay. So we have our address 192.168.40.1. So we're going to go over to host 2 here. I'm going to log into host 2. If if I can type right, maybe spell. Words are hard. Okay. Let's change the host name real quick. Host 2, and let's do a sudo config Congo fig. Internet 0, 192.168.40.10. We'll say we'll keep it the same principles as like we did the other host, so 40.10 with the net mask 2.5.2.5.2.5.0. Perfect. And then we're gonna do a sudo. Man, we did sudo. So many sudo hot, sudo route add default. So many defaultins. I think I'm defaulting default gateway, and we're gonna name our gateway the interface that we are connected to, so 40.1. What did I do? Did I break it? Let me try to ping router. Route. I think it's minus n. Right? Yeah. So route minus n just shows us the Linux host routing table there. So we have, yeah, save it. So let me just run that here. Minus n. Oh, see, it's got my gateway. Why is this not working? Let me just try that. Sudo route. Add. Doing that. Oh, I'm dumb. There we go. Dum dum. Okay, so now we have our default gateway. So many so's. So to get back to what I was curious about, what I wanted to see is now, so mind you, this host itself is living on its own network. This is a 40 network now. None of the other, and we can confirm all that, the other 3 routers have no idea of this host is network here. So we're gonna kind of confirm some of that stuff right now. So we'll go over to, what is it, R5. Yeah, so let's go over to R5. We'll show IP. So show IP route rip. So we don't have no details, or we have no entries advertising for the 40 network. Go to R4 and we You can see, yep. So the only one, so if we look at our IP routes though, you'll see a 40 for link local, for pretty much connected and local. For connected and local here, we have a route here on R4, but none of the other. R3 is the only last other example because we have R2 and R1 currently shut down. So as you can again to see, we don't have any entries advertising for the 40net. So to go back to it, I can be on host one here. Host one is existing on a known network. It's existing on the 10 network here with R5 and whatnot. So realistically, from host one, I mean, we can ping. I don't think I might be able to ping that interface on that router, but I will not be able to ping host 2. So we'll try it. So we'll ping host 2. So 192.168.40 and what is that, 10, right? Is that what we gave our IP address, right? It's 10. So let's do IF. Not config. Yep, 10. Okay. So I knew it because it's not a known network. Now, curious though, will host 2 be able to ping? Because now we're going in the opposite direction. Host 2 is living off of a unknown network, but R4 knows all the networks. So what is our IP address on host 1? So config 10.10. Okay, so let's go back to host 2. Ping 192.168.10.10. No, as I expected, it would not be able to do that. But I'm curious to know if the pings are going out, because R4 does know where that network is. It's just not that's something I want to see. If those are going, where are they going? Because I can almost guarantee their host 1 is getting them. And we can take a look at that actually. So we're gonna send from there. Yeah, so we'll inspect this line right here. Packet capture. Back to host 2. We'll start the ping. And we're gonna start capturing some packets and see what happens. Okay, that's enough. Okay, I'll take a look at that. Okay, so here's our request. Yes, this is our request coming. Okay, so here we go. just like I'd imagined, just like I said it was going to happen. So it's exactly how I said it was going to happen. So we're getting it from host 2. So host 2 is 192.168.40.10. Destination is 10.10. Now, the thing is because again, R4 knows where 10.10's network is. It successfully sent that, through the correct path all the way to it. R5 got it, and R5 sent it, sent it to it. Host 1 actually sent out a reply, and that's what we're looking at here. This is host 1's reply. So host 1 got the ping request, and actually sent back a reply. And here is our unreachable. So exactly. So we have our source. So this is 10.2. So this is R5 sending messages, unreachable messages to host 1 here. So that's what this is. And yeah, so destination. All right, so here we go. So source destination obviously is host 2 192.168.40.10. Destination address CMP. So pretty much what's happening is once R5 is getting the reply. Oh, jeez, broke my freaking reason for a person over here. Almost broke my microphone again. Once host 1 is sending the replies to R5. R5 right away says, "Man, I don't know where the 40 network is." So right away it sends the unreachable, host unreachable PDUs back to host 1, because it doesn't even know where host 2 is. Yeah, these, they keep coming in. So again, interestingly enough, we see how that works. And I can probably ping from host 2. I can probably ping though the interfaces that R4 has. So let's just go look at that interface brief again real quick. So we got a couple of them. 2, 3, 4, 1, 3, 2. So 192.168.2.3. So yeah. So just like I can imagine, yes, we can ping because R4 is host 2's default gateway. Host 2 is just going to send these messages out to R4. R4 in its routing table is going to do what it does best. It's going to route whenever it can, forward whenever it can, and obviously it knows where its interfaces are, so it can send those replies back to host 2. But outside of here, if R4 knows there's a route, it's going to forward that traffic regardless. It's going to forward it. Getting that traffic back, though, these other routers have no idea where this network is. So once they get it, that's it. It's going to stop right there. They're not going to know where it is. They're not going to forward it. Routers do not, they do not broadcast PDUs frames out just to anybody willy-nilly. They need an address. They need to know where they're sending their shit. Routers are responsible. They're not like switches. You know, these switches ain't alcoholics like hubs are. Hubs are the true alcoholics. But yeah, cool. All right, so we did that. We labbed that. Didn't have to change out of that lab. That's a rip. What time we got? How long have been going on for? Been going on 2.5 hours now. Maybe take a little break, eat something. Come back to it. Come back to it strong. Everybody think. Did I cover rip pretty good? I think I cover rip pretty good right now. We'll get back. Yeah, I'm just gonna take a quick break, guys. I'll come back in, you know, maybe an hour or so, and we'll continue on. And I want to tell you guys again, thank you very much for coming and hang out with me, and you know, spending your time with me is always well appreciated. You know, please, guys, make sure you guys like, share, and subscribe. And please, 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 if you find it in your heart, please help a brother out. Make your way over to the Buy Me Coffee page there and support a brother. I truly do need it, more than ever right now in my life. I wouldn't be asking if I didn't need the help, but I need the help, guys. And yeah, I'll get into that a little later if you guys want to talk about that. So I'm on another stream or something, but now we're focusing on that. So yeah, that being said, guys, I will probably catch you back in probably about an hour or so. I'll be back on streaming and studying and stuff like that. And we'll move on through our routing protocols.